Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem longest substring with distinct characters, which is an easy level problem. And we are going to learn a new approach here. Okay, so let's read the problem description. Given a string as, find the length of longest substring with all the distinct characters. So the description is very clear, right? That we have been given a string as, now we need to find the longest substring length with all distinct characters. That means that substring should have all the different characters. Okay, so if you see the example, in the example 1, the string is this and the output is 7. How? EKSFORG. So if I zoom in, so starting from this till this G, okay, this much window has unique characters, right? Like EKSFORG, right? Every character is unique and the count of characters are 1 2 3 4 5 6 7, right? So that's why the output is 7. Similarly, if we look at the example 2, the string is AAA and the output is 1 because A is the longest substring with all the distinct characters. Even if we try to take two characters from the string, it will be AA, and since these are not unique, so we need to consider only one element, right? We need to consider only one element. And finally, in example 3, the string is this and the output is 6 because the longest substring with all distinct character is ABCDEF, right? So if we try to map it in the example, ABCDEF starts from the starting position and goes till this position, right? So this is the window, right? This is the window, and in this window we have 6 characters. That's why the output is 6. So we have also understood the examples pretty well, right? Now let's see the constraints to get the idea about the time complexity. The string size at max can go till 10 to the power 4, right? So we can solve it in order of n square, right? So the worst time complexity that we can solve is in order of n square, and all the characters are in lowercase. So all the characters from the string will be from small a till small z, right? So we have also understood the constraints, right? Now let's take example 1 as reference and we'll try to find few observations from it. Now here the string given is this. Now what we need to find? We need to find the length of longest substring with unique characters, right? With unique characters. So how can we solve it? Now what is the brute force approach to solve this problem, right? Now let's suppose we start from index 5. Okay, we start from index 5. So we are starting from index 5 and it is a single character, right? So it will be unique. Being at index number 5, we go to index number 6. Now we have two characters as unique, right? So we'll try to expand the window. Now let's expand the window more, right? So R got added and which is unique in this substring, right? So again expanding the window, G again unique, then expand the window, E again unique. Then when we come at index number 10, the character is E, right? But we have already seen E at index number 9, right? For the substring. So the condition is violated. So we'll stop our execution till index number 9, right? Given that we have started from index number 5. Now if we try to check the length will be 1 2 3 4 5, right? We have 5 characters, so the length of the string starting from index number 5 will be 5. So in the same way, from every point we'll try to increase the window. Like when we are index number 0, we'll increase the window and increase the window. Now when we see the character occurring again, then we break the loop and we'll consider only the window which has unique characters, right? So for this we need to use two nested for loops, right? So what will be the outer for loop? Outer for loop will be determining the starting position, right? Starting position. And the inner for loop will be for how long we can expand the window, like how long we can expand, right? Now here the outer for loop will be easy because we need to start from each and every position, right? But how do we implement the inner for loop? When we are at position 5, we looked at position 6. What is the character? O, right? And we were checking whether O existed in the past. If yes, ignore. But if no, add that O and again expand the window. So from F and O, we looked at R and checked whether R existed previously. No, right? So we included it and expand the window more. Now, when we are at a particular character, how can we check whether that character have existed or not in previous substring? Basically, we can run one more for loop, right? So when we are at R, we can run a loop from here to here and check whether R exists, no, whether R exists, no, right? But that is very tedious thing. Now, instead of using for loop to check the character, which takes linear time complexity, can we optimize the time complexity for searching a particular character in the word? Yes, you are right. We can use hashmap. We can use hashmap. Now, how can we use hashmap? Whenever we are at particular character, we'll check whether that character exists or not. So when we start at character F, we check whether the character F exists in hashmap or not. It doesn't exist, right? So we create an entry of F with frequency 1. Okay. Now when we are at O, we check whether O exists in the hashmap. No, right? So we'll create one more entry, O with 1. Now again, when we are at R, we check whether R exists in the hashmap. No, right? So create an entry and increment it 1. Now at character G, whether it exists in hashmap. No, right? So create an entry with frequency 1. Now at character E, it doesn't exist. So again, entry with frequency 1. Now when we reach at this second E, right, we check whether the entry exists. Yeah, entry exists with the frequency 1, right? That means we have already seen E in the past substring. So we can stop our execution here, right? And whatever the map size will be, we create a global variable, max length, right? Max length. And we'll update our max length with the current map size starting at every ith position, right? So when we consider at 0th index, the map size will be of size 2 because this will be the only two characters. And again, when we are at index number 1, the map size will be 1, right? So at each starting position, we maximize our max length with the current map size. Okay. So I hope you guys understood the intuition behind brute force approach, that why we use hashmap and why we are using two nested for loops, right? So now let's see the code. So here's the code in C++, although the logic remains same. So the function name is longest unique substring and a string is passed to us. Now firstly, I have taken the string size and stored it in n, okay? And we have created a max length variable. Now we are running two for loops. The ith for loop to determine the starting position and jth for loop to start from I and go till n. So inside the ith for loop, I have created a hash map of key character and value integer and have declared a current length variable. Soon we'll be seeing why did we use current length variable. Okay. So inside this for loop, firstly we are checking whether map consists scr of j, basically the character, the position that we are at. Okay. So if it exists, then we break the loop. Else we add that entry inside the map and increment its count by 1 and also increment the current length by 1. So the job of this window is to expand the window, and whenever we find the same character that is already present in the map, we break out of the loop, right? So after breaking out of the loop, we'll maximize our max length with the previous max length and the current length, right? Now here, instead of using current length which we declared here, we can directly use the map size because we are creating an entry in the map and incrementing current length simultaneously, right? So both of this will be equal. So when this loop gets executed, we will consider every ith position as starting position. Whatever the max length that has been generated, we'll simply return it. So this is the simple brute force code, right? Now, what will be the time complexity of this approach? Here we are running an outer loop from I equals to 0 till n. So the time complexity will be order of n. And here again we are running a loop from I till n. So in the worst case scenario, this loop will also run till n position, right? And here we are checking whether that map consists the entry of the particular character or not, which is order of 1 because we are using hash map, right? So the overall time complexity will be order of n square. But instead of hash map, if we would have used the conventional method to iterate from ith position to the j minus 1 position to check for the character of jth position, it would have taken extra O of n, right? So the overall time complexity would have been order of n square. But by using hash map, we reduce it to order of n square. And what will be the space complexity for this approach? For the every ith for loop, we are creating a hash map. And in the worst case scenario, all the characters in the string will be unique. So the map size will also be equal to the length of the string, right? So the space complexity will be order of n. So these are the time and space complexities. Now, if you try to submit this problem, the solution gets accepted, right? Because we already saw in the constraints that the worst case time complexity can go till order of n square, right? So it is exactly order of n square. So the solution gets accepted. But can we further optimize this solution? Now, how can we optimize the time complexity? Now, what was going wrong with our brute force approach? If we look at this example, it will get much more clear. Okay. So, starting from index 0, the character is A, right? So, we create an entry of A with frequency 1 in the hash map, right? Now, we expand the window and we'll check whether B exists in the hash map. No. So we create a B entry with 1, right? Now we increase the window till C and check whether the entry of C is present in the hash map. No. So we'll create an entry with 1. Now increase the window till D and D is also not present, so D with 1. Now when we increase the window to A, now we already have the entry of A inside the hash map, right? So we stop the execution starting from index number 0, right? So if I write properly here, from index number 0, the string was A, B, C, D, right? Now again we start from index number 1, right? So we used to reset the whole hash map by clearing it, right? But for a moment, let's keep the hash map somewhere else, right? Okay, let's keep this here. Okay, so for B, the entry is 1, right? So we create an entry with 1, okay, and we expand the window. So when we expand the window, C is not there, so C with entry 1. Then again D is not there with entry 1. And again, when it comes to A, the entry of A is not present, so A with 1. Now we expand the window till C and check whether the entry of C is present inside the hash map. Yes, it is present, right? So we stop the execution. So when started from index number 1, the string is B, C, D, A, right? We have this substring as longest unique characters. Now if we try to map this substring started from A and went till D. And the second substring started from this B and went till this A, right? Now, do you see something common between these two substrings? Yes, we had B, C, and D's entry as same in both of the maps, right? So if we check B, C, and D, and this B, C, and D, both are same. Now, when starting from index number 0, we already have computed B, C, and D, right? So when starting from index number 1, we were resetting our whole map, right? So if you check here, we were resetting the whole map, right? So while resetting it, we again computed B, C, and D, right? Which is an extra work. So if you would have reserved these values, there would be no recomputation of these characters again, right? So that is the main intuition behind optimizing the solution. Now again, if we try to map these values inside the string, the first substring was this much and the second substring was this much, right? So this was constant, this got removed and this got added, right? So something is getting removed and something is getting added. So if we consider this substring, we remove this character and added this character, right? So we are shrink the window from here and expanded the window from this position, right? So it is a sliding window problem. Are you getting what is the intuition behind optimizing the solution? It is a sliding window problem with combination of hash map. So now let's take the original example and we'll dry run to get the full clarity on it. So here's the string where we need to find the longest unique count, right? And here's the map where the key is character and the value is frequency. Okay. So before proceeding, we need to create two pointers, one the left pointer and another the right pointer. Now, why are we doing this? Because these two pointers will help us to keep the track of where's the starting and ending position of the particular substring where we have unique characters. Okay, so this right pointer's job is to expand the window and the left pointer's job is to shrink the window. Better while dry running this example, we'll get it. Okay, so firstly we need to expand the window, right? So we'll check whether this G exists in the map. No, right? So we create an entry G with frequency 1 and move this pointer by 1. Now when we move this pointer by 1, the window will be this much. Okay, now we'll check whether E exists in the map. No, right? So we create an entry of E with 1. Now again we'll shift our R pointer by one step ahead. Okay, now here again the character is E, so we'll increment its frequency. So the frequency will be 2. Now we'll check whether the frequency is greater than 1. Yes, the frequency is 2, right? So we need to shrink the window. So inside this window we have a duplicate element. Now as we see in this substring, we have duplicate characters. Now it's time for L to shrink the window. Now, while shrinking the window, we constantly keep the track of characters present at index R. Now, to shrink the window, we'll decrement the character present at lth position by 1. So, the frequency of G will be 0, right? And we'll move this pointer one step ahead. Now, what does this signify? The E equals to 2. We are at this window, okay? Again, we check the status of E. So, the Eth frequency is still 2, right? So, we'll decrement its count by 1, okay? And shift our L pointer one step ahead, right? Now we again check the position. Now we again check the status of. Now again we check the status of E, but at this time the frequency is 1, right? Again we check the status of E, but now the frequency is 1, right? So it's time to expand the window. But before that, let me clean this down and write it. So as the character E has a frequency 1, it's time to expand the window. We'll take R to one step ahead. And now the character is K and it is not present in map, right? So we'll create an entry with frequency 1. Now again, we'll move this R pointer by one step ahead, right? Now again, we'll check whether we have S in the map. No, right? So we create an entry of S with frequency 1. and again expand our window. Now we'll check whether we have f entry in the map. No, right? So create the entry with frequency 1 and expand the window, right? So our pointer will be one step ahead. Now we'll check whether we have o in the map. No, right? So create the entry o with frequency 1 and again expanding the window by shifting r one step ahead. So do we have r in the map? No, we don't have r in the map, right? So with r the frequency will be 1, right? And expand the window. So when we expand the window, the character is G. Now, do we have the entry of G inside the map? Yeah, we do have the entry, but the frequency is 0, right? That means this G character doesn't exist at all. So we'll increment its frequency by 1. Okay, so the frequency will be by 1. Again, let's expand the window. So R will be one step ahead. Now we have a character E, right? So we need to increment its frequency. So the frequency will be 2, right? So the frequency would be 2. Now if we check, we have a frequency of 2, but our frequency should be less than or equals to 1, right? So we'll try to shrink our window. So to shrink the window, we'll erase the entry of this E from the map. So if we try to erase this entry, the frequency of E from 2 will become 1, right? So it became 1 and we'll shift our window by one step ahead. So L will be one step ahead. Now we have found a substring from position L till R, right? Where we have all the unique characters. So what will be the length of the string? The length of the string will be r minus l plus 1, right? So if we check manually, it is 1 2 3 4 5 6 7, right? So the length is 7, and if we try to submit the r and l values in the formula, so r is 9, right? So r is 9, l is 3. 9 minus 3 plus 1 will be 6 plus 1, which is nothing but 7. So to calculate the length from L till R, we use this formula generally, and it is one of the most widely used formula to calculate the length from position L till R. Okay. So we'll be using the same code. So we'll be using the same formula in our code. Now, since we got the length of 7, we need to update our max length, right? So we never created max length. So let me create it, which will be initially 0. And when we were at this window, the length was 2, right? So it would have gotten updated to 2. And when we were at this window, the count is 1. But when we are at this window, the length is 7. So the length will be from 2 till 7. Now again, we'll move our R pointer by one step ahead to expand the window. And if we find any duplicate inside the map, we shrink our window by moving L one step ahead at every iteration, right? So this execution continues like this. But for this string, the maximum length is 7, which we have calculated, right? So the maximum length is 7. So I hope you guys understood why do we need to use sliding window approach with hashmap used. Okay. So let's see the code. So again the code in C++, but the logic remains same. So firstly, we have taken the string size and stored it in n, right? And we have created a max length, which is initialized to 0. And here we have created a hash map, right? So here we have declared a left pointer and assigned to 0, right? And we are running a for loop for right pointer starting from 0 till n, and every time we are incrementing it by one step. So firstly, we are adding the entry of str of right inside the map and incrementing it by 1, right? And inside this for loop, we are checking until when we have str of right, the frequency of this greater than 1, we are decrementing the left pointer character by one step and shrinking the window by incrementing left pointer every time with 1, right? So this phase is shrinking phase, and after coming outside this loop, we are updating our max length with the previous max length, comma, right minus left plus 1. And you know why do we use this, right? So this way, here we are shrinking the window and here we are expanding our window. So after this whole execution gets completed, we are returning our computed max length. So for now, what will be the time complexity for this approach? Here, by looking at these two loops, you might be thinking that the time complexity will be order of n square, right? But this for loop is to expand the window and this while loop is to shrink the window, right? So if you notice carefully, we never visit any character more than 2 times. So if we take both left and right pointers, each time this left pointer and right pointer will visit the character only once, right? So whenever we are at R here and L here, this R would have already visited it and L will also visit only for the one time, right? Right. So this will be also order of n. So the time complexity will be O of n plus O of n, which is nothing but O of 2n. So if you approximate it, it will be order of n, right? So the time complexity is order of n. And what will be the space complexity for this? As you already know, we are using a hash map, and in the worst case scenario, we need to store each and every character frequency inside the hash map. So the space complexity will be again order of n. But one thing I noticed is that in the hash map we store only the lowercase characters, right? And the lowercase characters will be from A till Z, right? So the space complexity will be order of 26. So will it be order of n or order of 26? You guys let me know in the comment section, okay? And instead of using hash map, we can directly use hash set to solve this problem because we need not be caring about the frequency, right? So you guys commented down how can we solve this using hash set. So by using the sliding window approach with hash map, we have boiled down the time complexity from order of n square till order of n, which is a huge optimization, right? So I hope you guys like this video. If you guys really did, then please like, share and subscribe to my channel. It will really motivate me to bring more such quality content for you guys. If you guys have any query regarding the explanation, you can comment it down. I'll try to respond to it as quickly as possible. And if you guys have any suggestion for my teaching, please comment it down too so that I can improve and provide the best quality content. So see you guys in tomorrow's video solving any other kind of problem. Till then, stay safe, stay happy and peace.